In this video, we're going to go over the naming and chemical formulas of ionic compounds that contain oxyanions. So that is a mouthful. I think we need to first start with what is an oxyanion. So an oxyanion is a polyatomic ion that contains a negative charge and contains oxygen. Now the naming can be a bit tricky because the names of the different polyatomic ions differ on how many oxygen atoms are present within that polyatomic ion. So for example here, chlorate is our ClO3 minus polyatomic ion. We also have chlorite, which is one less oxygen. We have hypochlorite, which is two less oxygens. And then we have perchlorate. So the naming can be tricky because the namings do change depending on how many oxygens are present in the polyatomic ion. So how do we know what name to use and when? There's actually a fairly easy trick to this, and part of it goes to you have to remember what the typical polyatomic ion is to begin with. So for example, in this example of series of oxyanions here, chlorate is the typical polyatomic ion. And in terms of its naming, its name is chlor and then ends in an 8. Now, if you don't remember what the polyatomic ions are, I do have a separate video on that. I will link that in the description below. You can go check it out. From there, you can base all of your names based on the 8 ion. So if you have one less oxygen, so going from ClO3 to ClO2, the naming changes by the change in the ending to ite. So instead of chlorate, this becomes chlorite. If you go two less oxygens from the typical polyatomic ion, the naming gets a hypo in the front, and then it gets an ite on the end. So this becomes hypochlorite. And then finally, if you have one extra oxygen, so going from ClO3 minus to ClO4 minus, the name changes by adding the per and then leaving the ending as 8. So this becomes a perchlorate. So in terms of memorization, you need to know these base polyatomic ions, but then you can derive all of the names of the oxyanions based on that base one there. So a little bit less memorization, which is always a good thing in chemistry. Let's go through some examples then and take a look at how we name this. So the first one we've got is NaNO2. Now, what you want to do is look at the polyatomic ion NO2 and ask yourself, what is the base polyatomic ion? In this case, it's NO3. And so this is our nitrate polyatomic ion. Now, we are one less oxygen here, so the ending is going to change to an ite. So this compound becomes sodium nitrite. We're changing that ending from 8 to ite. Looking at our next one, AlPO2, we need to know our typical polyatomic ion is PO4 3-, and this is two less oxygens. So this is going to become aluminum. And then we need to go 2 down, so it's the hypophosphite. The next one, KBRO, sorry. I'm thinking the typical polyatomic ion is BRO3-. Again, we are two less oxygens, so that's going to become our potassium. Hopefully I spell potassium right. And then our hypo, and then this is the bro, and then mite. So potassium hypobromite. And finally, CaSO5. SO4 2- is our typical one. This is gaining one oxygen. So it is going to become calcium per sulfate. So really the key is identify the typical polyatomic ion and then base your name based on how many oxygens more or less it has from your base polyatomic ion. So that is it for this video. We'll see you in the next one.